and let's start your heat and mass transfer snap for your final DRDO interview. So,
Yes.
Kirti, what do you know about heat transfer?
Sir, it is a phenomena which occurs due to the temperature difference.
Mm-hmm.
Uh,
So that is the only one line you know about heat transfer.
uh, Sir, temperature difference because of
Mm-hmm.
temperature difference, heat flows from higher temperature to lower temperature.
Okay. So, can you tell me something about different modes of heat transfer and the basic difference, the mechanism of actually in brief? You need to tell me the mechanism of different modes of heat transfer.
Sir, it can be because of conduction, convection, or radiation. In conduction, it occurs because of molecular vibration uh, between the solid materials and or electron transfer of the in the material. And in convection, it can occur due to the bulk macroscopic displacement of the fluid particles. And in radiation, it does not require any medium
Mm-hmm.
for the transfer of heat. Uh, any material which is above 0 Kelvin, it can radiate heat um, mm, in radiation heat transfer.
Okay. So, which particular law of heat transfer actually governs convection heat transfer?
Sir, for convection heat transfer, we calculate uh, Newton's law of cooling.
Mm-hmm. Can you explain that law?
Uh, yes, sir. In this,
Mm-hmm.
if there is a bulk motion of any fluid from a surface, it will transfer heat from the higher temperature to lower temperature, and its formula is given by Ha delta T. And
So, what is that Newton's law of cooling? You need to explain Newton's law of cooling. What is Newton's law of cooling?
um, uh, so
Mm-hmm.
um,
Okay. So, Kirti, according to that law, we write that convection heat transfer,
mm,
Q convection, is directly proportional to the exposed area of the body, and it is also
yes, sir.
directly proportional to the temperature difference.
Temperature difference, yes, sir.
Okay. And when we remove those kind of proportionalities, we introduce some constant we can
uh,
know as
Convective heat
convection heat transfer coefficient. Okay,
coefficient,
that is
yes,
also
sir.
not a property. So now
uh,
can you tell me what is that convection heat transfer coefficient and on what factor actually it depends and how we can enhance that H value?
Sir, convection heat transfer is not the property of the material. It depends on many factors. For example, um, it will depend upon the viscosity, density, and
Mm-hmm.
dimensions.
Okay.
So,
Acha, for example, we are using some fan. Okay,
uh,
the speed of the fan we cannot change, let's say,
okay, sir.
and some maybe hot tea is there
Mm,
and we want to cool it faster by
mm,
enhancing the convection heat transfer coefficient. Fine.
mm.
So what you can do to increase that convection heat transfer coefficient in that case? How you will increase the convection heat transfer coefficient? Or it is not going to change. It is a constant.
Yes, sir. We can stir the liquid inside the cup.
Hmm.
It will increase the area of exposure area, due to which the convection rate will increase.
Stirring is going to increase the area, exposed area.
Sir, for example, if upper layer is now in contact with the air. But if we stir, the molecules which are below the upper layer, they will come now in contact with the air, and this is how the heat transfer will increase.
So are you sure about that? Like when you are stirring the what you can say, the area, exposed area is going to increase. I don't think exposed area is going to change when we are going to stir some maybe liquid in some container.
No, sir, exposed area is will not increase. The molecules which are
So what is
coming
going
in
to increase? What is going to increase?
Mm. Sir, for example, the
Mhm.
hotter molecule which is now resting below the T surface, T cup, will now come above because of its lower density, and it will
Acha, can you tell me something about bulk mean temperature, Kirti? What is bulk mean temperature?
yes, sir, it is the average temperature at that cross sectional surface.
So how you can
Sir,
evaluate bulk mean temperature?
um, sir,
How it is different from film temperature?
yes, sir. Sir, we calculate it by equating the uh, energy equation. For example, MCP delta MCP T. We can here take rho, mass is taken as
Mm-hmm.
here we can for example we can take a cross sectional area of the pipe in which there is that temperature gradient exists, and we can write the equation of energy by rho 2, and taking a cross sectional area as 2 pi r dr, and velocity will be at ur at that r instant, and T will be the temperature of that of the layer which is distance from the center, and we can write equate it with the energy by average, taking average temperature and average velocity, and we can write rho pi r square, and u mean and temperature mean. So by this we can get
Okay. Kirti, what is Biot number? And what is the significance of Biot number in heat transfer?
So Biot number is the ratio of resistance of that solid body, conduction resistance of that solid body to the convection of the fluid, and it should be very small so that the conduction resistance is very small, and hence the temperature gradient does not exist inside that small body, and then we can assume that the body as a lumped body to solve our problems.
Mm-hmm. Okay. Can you explain Wings displacement law, Kirti?
Yes, sir. In this Wings displacement law, it tells that lambda is inversely proportional to the temperature, and its formula is given by lambda into T is equals to 2898. And
Acha, can you give me some example of this? Can you give me some example?
um, Sir, I'm trying just like, for example, the radiations which are coming from the sun to Earth, it's have very high temperature, and so its wavelength is very small, and it's easily penetrate to the atmosphere of the Earth. But it is observed in greenhouse effect that because the when this high wavelength, but when this temperature of the wavelength decreases, its wavelength increases, and it cannot then go back to the um, cannot escape
Okay,
the
fine.
earth.
Mm-hmm. Fine. So Mm-hmm. Kirti, can you explain what are gray surfaces? What?
Hmm. Sir, in gray surfaces, so for example, in real surfaces, we observe that emissivity at a particular wavelength is a function of wavelength. It depends at different wavelength, its emissivity is different. But in gray surface, we assume that the emissivity is not a function of lambda or wavelength. It is constant throughout, and we assume it is. We assume that emissivity is constant is equals to epsilon.
Kirti, when we start heating iron, maybe suppose some iron rod or maybe any iron block if you take, when you start
Mhm.
heating it, it turns into, some kind of red hot,
Mhm.
red color. So white, converts into red. Why not green or maybe yellow or maybe any other color?
Sir, as we see in the spectrum Vibgyor, the red have very high energy, and its wavelength is very small. So when we increase temperature,
I'm sure about
uh,
that because in with Cure, if you see the energy of violet is the highest, whereas red is having the energy least.
okay, so, mm, um, sorry, sir, I'm
Okay.
not.
What do you understand by fully developed flow?
Sir, in after the fully developed region, there is no change in temperature profile.
My last question to you, Kirti. Can you tell me the differences between the film and drop wise condensation and how we can achieve the drop wise condensation?
So I'm not sure about this, but in film there is a layer of liquid on the surface, whereas in
Mhm.
dropwise at the discrete places there are drops forming, and
Okay. Okay. Okay, Kirti. I think now I can provide you the feedback. So overall, Kirti, your answers are looking fine, but you are not looking much comfortable, and even thoroughly you have not revised. I feel this subject. Okay,
Mhm.
so basic questions you are answering. There is no such major issue involved. Your confidence, your energy level is looking fine. But if you observe this video, later stage, you will find this video on the panel. You can watch that. You will find, your delivery answers are expressionless. You're not giving much energy and expression in your answers. Okay, it's looking like just answering. So in interview, you need to put efforts in convincing the interviewer about some specific, the points which you are mentioning. So you need to feel
Uh-huh.
those things, and then very positively you need to highlight those things in front of the interviewer with all kind of body language, facial expressions, and with good energy. Okay, so that part is missing. Those are
Mhm.
the kind of observational feedback.
Okay,
Next,
sir.
technical understanding is looking fine. Not much issue. Basic things you revised, but when I'm going into slightly more detail, then you are
Mhm.
facing difficulty, and even you are only highlighting one line and then you are skipping, and it is looking like you are not showing interest in answering those questions. That is actually very serious for DRDO and ISRO kind of organization, because if you're going for research organization,
Mhm.
you need to be confident, and at least you need to show the interest. If interviewer is asking you some linked question, so at that time I observed you, you have shown some kind of lack of confidence in answering those kind of questions. Okay, so have confident, apply your mind. Whatever
Okay.
interviewer is asking you, whatever basic knowledge you acquired by studying that particular subject, try to link,
Mhm.
okay, relate with that question, and in best possible way you can try to answer. Okay,
Mhm.
so it should it must look like yes, you are trying hard for answering that particular question. But if it is not looking like that, it means you are not interested. And even if you are not interested in applying your mind, that is very serious for these kind of research
Mhm.
organization. Fine. So you need to be very
Yes.
much confident, and you need to show your interest in relating the things. Okay.
Okay, sir.
Now let me discuss some of the basic things with you. I asked you about the heat transfer. You answered one line only. Then I asked you about the modes of heat transfer. Then which law governs heat transfer? You missed actually that the Newton's law of cooling. You have not defined proper definition of that law.
Mhm.
Convection heat transfer coefficient depends on many factors. It depends on the let's say case of forced convection. So it depends on the velocity of the fluid. Okay,
Mhm.
it depends on the characteristic dimension. It depends on the thermophysical property like rho, mu, cpk. Okay, in case of free convection also it depends on various properties, thermophysical and other parameters. So by enhancing those things, we can enhance the convection heat transfer coefficient.
Mhm.
So one example you have given, ki sir, by steering we can enhance the heat transfer. So when you are steering, the exposure area is not going to change. Whatever is the area, that is going to remain same. Okay.
Yes, sir.
Even when you are doing some work, you are doing some work. Okay. Obviously, some heat it will convert into the heat, and that will also go into the surrounding. Okay.
Yes, sir.
Slight increase we can get due to what? Due to a kind of intermixing of the fluid.
Uh,
Okay. Or what you can say ki yes, initially maybe suppose in the bottom, because the hot fluid we are having at the top, at the cold we are having some cold fluid. So due to some kind of difference of temperature difference, because the everywhere temperature is not same, so heat transfer may be different in that case. It may be higher from the top but maybe lower from the bottom surfaces, because the colder fluid is going to come down due to the higher density and the hot fluid will come up. So when you
sir,
are
so
mixing
steering
the
will
fluid,
not steering will not decrease the temperature of the fluid.
no, it is not going to decrease the temperature, but it is going to, just a kind of uniform temperature we will get throughout.
Okay.
With the time, the heat, obviously, the fluid is going to lose its heat. Okay.
Mhm.
When you are carrying out the steering, it means everywhere you are maintaining some constant bulk mean temperature. Okay,
Mhm.
bulk mean temperature is also known as mixing cup temperature. So if you are having a cup of tea and if you will start stirring it, that
Mhm.
particular temperature of that fluid, that is nothing but mixing cup temperature or bulk mean temperature, or it is
Yes.
also known as energy average temperature.
Mhm.
Fine. So that will become some constant, and you will be able to assume some, at a particular instant of time, TB, maybe some TB, bulk mean temperature, minus T infinity. That will be the temperature difference.
Mhm.
Okay. So you need to relate ki, so this can happen if I will start steering. Okay. You can increase the exposure area by providing some fins over the cup. Whatever cup you
Mhm.
are having, if you provide some kind of, fins over that, then you can increase the exposed area. So
Okay,
that
sir.
thing you can highlight. By enhancing the exposed area, we can enhance the heat transfer, and
Mhm.
area we can enhance by providing some kind of fins. Okay.
And so
Velocity I already.
that question in which iron was appearing red.
When iron is at low temperature,
Yes, sir.
whatever radiation energy it is going to emit. Okay, those will be high wavelength radiations because it is at a low temperature.
Mhm.
Okay,
Mhm.
so when you will start heating it, it will start emitting radiations of what? Lower wavelength.
Mhm.
Okay, so initially when it will enter into that zone, okay, it will enter into what? Red color only. So when
Okay.
it will become hot, because that is the only visible reason, that is the only
Mhm.
visible reason to us, so it will enter into the red hot. Further heating the iron, it will start converting into kind of yellowish color,
Okay.
yeah, orange, kind of orange and then yellow, kind of yellow orange mixed color we will get. So sometime interviewer can ask you which one is more hot. Suppose you are having two iron block, one is yellowish, yellow orange hot, another one is
Mhm.
red hot. Which one is more hotter? So yellowish orange,
Yellowish.
yellowish iron is more hotter. Why?
Mhm.
Because its energy level is higher as compared to red hot. Why it is not converting into green or maybe any other blue color? Because we get the color based on the radiations a body is emitting, and radiations is not going to a body is not going to emit a radiations of single wavelength.
Mm.
It's going to emit radiations of different wavelengths, some lower, maybe some higher. So we are going to get the color based on that, maybe some mixed color. Okay,
Yes.
so red is a dominating one at some higher wavelength. Okay, that's why it will be visible to us a kind of red color. So as the temperature is going to increase, some mix of color we are going to get. So sometime when the two colors mixes, we get some different color. Okay, the dominating
Mhm.
one, or maybe resultant color which we get by mixing two colors. Okay, that is the
Yes.
reason we are not going to get a one single green color, because the iron or maybe any body is not going to emit a radiation so one single wavelength corresponding to that green color. Fine.
Okay, sir.
So if you plot eb lambda, what is lambda plot, you will find some curve. Okay, and that curve, the MSC power is going to increase with the increase in wavelength. It will become
Mm.
maximum, and then again it will start decreasing.
It's
So the
decreasing.
area under that curve is nothing but what, the total MSC power.
Emissive power. Yes, sir.
Okay, so a body emit radiations of different wavelengths. Some maybe in high wavelength, some maybe in low wavelength radiation. So based on that, we will get some color. Fine,
Yes, sir.
Kirti.
Yes, sir. Yes, sir.
I think these are the question I asked you. I asked you one two question from Wings displacement law also. That I
Mm.
think you answered. But I asked you just to give me some kind of examples that you missed, I think. So you can give example of greenhouse effect. Okay.
Sir, I gave you that example, greenhouse effect.
Uh, Fine. I think I missed that. I don't know like how much up to what part you mentioned about that greenhouse effect. But you need to explain that greenhouse effect. You can highlight,
Sir, I
and
told you
even
mm,
yes, yes.
I told you that the rays from the sun will have a high energy, but when they will enter, therefore they will enter the atmosphere.
Mhm.
But after that, the wavelength will increase, and they cannot escape through the
No,
earth. Therefore,
fine, fine. So mathematically, you can explain it that low as the product of lambda into t is constant. But if you plot
mm,
EB lambda versus lambda curve, so that curve is going to shift towards left.
ah,
As we are going to increase the temperature of a body, the EB lambda versus lambda curve will shift towards left.
ah,
Okay, uh, so that is going to displace. That curve is going to displace towards left as you are going to increase the temperature. Okay,
mm,
that further you can add Wings displacement law.
okay, sir.
So high temperature body like sun, they emit radiations of shorter wavelength.
Mm,
Low temperature body like human body, the interior of our room, earth, they emit radiations of longer wavelength.
longer.
ठीक है कीर्ति?
Yes.
तो अभी ये आपने कंडेंसेशन वगैरह नहीं पढ़ा है, आई
हाँ
थिंक.
सर वो तो
Boolean
हाँ
condensation, and so that part is also important. Go through that also. Okay,
ओके
and try to get some more idea about solar panels, the losses in heat transfer from a panel, heat pipe. Okay, working of heat pipes, and some kind of questions maybe related to processor, maybe how cooling we carry out in laptops or electronic component. Some basic questions related to critical radius, critical thickness of insulation. Okay, so you can have one more snap with me, revise thoroughly this subject. Okay, and join me again.
ओके
Fine.